I will be conducting the two sessions for today. The second will be on the case study of IoT. So first of all, let me tell you, this is session one, which is resource optimization. So before I start with what resource optimization is, I need to say something about Internet of Things. Like I will introduce what IoT is. IoT are complex environments. Like these are not simple environments. These are complex environment and these encompass many heterogeneous components. The objects that are present in an IoT environment, these can be heterogeneous. That means there are different specifications that they can have. Now, IoT, it embodies a vision of merging these heterogeneous devices and they utilize internet. As you can see, the first term is internet. So the internet is used as a backbone of communication to connect these things, and these things are heterogeneous. So IoT is a
Excuse me, ma'am.
platform. Yeah.
I hope you have not shared the slides yet.
Okay.
We
That's
cannot see the slides.
You cannot see the slides. Okay. Uh,
Is there
okay.
any issue? Okay.
No. Is this PPT
Yes,
visible
yes,
to you now?
yes,
Okay.
yes. It's
Thank you.
visible.
Thank you. So IoT, what I was talking about, these are the complex environment, and there are many heterogeneous components that we have in this. So I was talking about IoT as a platform. Like you can see, it's a platform where everyday devices can become smarter because you can connect a simple object. For example, you have a pen, you can have something, you can make it smarter, and we can get data about you. Okay, so everyday devices can become
I
smarter, and processing can become intelligent, and communication can become informative. So there are a huge number of devices connected to the internet. So we require an educate architecture that will permit easy connectivity and control. Like we require an easy control, and we need a mechanism by which we can control these devices. And for that, these devices need to be connected. And how they are going to be connected? They are going to be connected over the internet. So there is no universal architecture that is used for the IoT. Like I cannot say like there is one universal solution that you can follow. Yes, it because the problem is that IoT encompass a wide range of application. So a simple or a basic IoT architecture, if we have to say, it should have three layers. Like there should be a one layer that should sense the data. Obviously our IoT devices, it sends the data. Then we need to communicate this data. Then communicating this data for what? So that we can utilize this to provide services at the application layer. So IoT encompass objects. Now the problem with these objects is that many of the objects that we have in IoT devices are resource constrained. Resource constrained means they are resource limited. Like there is a limitation in the storage, processing, bandwidth, and energy. If you talk about small WSN modes, those are IoT devices. They have limitations in the storage as well as energy. So a lot of research is going on these topics. So it's difficult to envision a real world IoT devices without including some powerful platforms like we have cloud. What we do, we push the data from the IoT devices to the cloud, and we have many other powerful devices like edge, fog, and so on, which I will tell you later on what these devices are. But you can see this leads to the three-tier IoT architecture. For example, if my IoT architecture would have, okay, is this screen visible? Is this screen visible?
Yes, it is visible.
Okay, now if I have only IoT devices, these sense the data and they have limited storage. I need to push the data from these devices to some powerful devices, maybe edge, and then edge to the cloud. So this leads to the three-tier architecture. There is a IoT devices. There are IoT devices at layer one. There are edge devices at layer two, and there is a cloud at layer three. So that's what I'm saying, that we need to incorporate IoT device, these powerful devices or powerful platforms in our IoT environment. So the resources that we have, like obviously my topic is on resource optimization, but we need to understand what are these resources. We can categorize these resources into physical resources, into virtual resources. Physical resources, you can say there is a storage unit, there is a CPU, there is a battery that you can change. Then coming to the virtual resources is, we can take an example of various protocols and algorithms that you use in processing storage, and you can use some, like you can use the daily some resource efficient protocols, or you can say some, there are some other algorithms that you can use in storage, in processing, in fusing the data, in aggregating the data. So a lot of mechanisms are there, or processes are there, that play an important role in the IoT environment. Now, if there are resources, there are constraints, but these constraints are not only at the device level, like at the node level. Whenever I say a term node, it means device. These are not only at the device level, these are at the network level, these are at the application level. So, but there is a difference. Like at the node level, we talk about the storage, processing energy, and the bandwidth of that node. But at the network level, we talk about the behavior of the network. For example, if one node dies, the topology of that network can change, right? And at the application level, there are also constraints. For example, there is one application which is low latency, like they just want the data immediately, they want the results immediately. If we talk about some healthcare application, we have low latency, that is, we want the data back in a definite amount of time. So this is a constraint. Okay, we have to take care of this constraint. So then processing of the data, like processing of the data can be a second example. For example, there is a application, if we talk about weather monitoring systems, they generate a huge amount of data, and processing of this bulk amount of data will require cloud. So pushing the data to the cloud means there will be some sort of delay. So there are certain limitations when we talk about. So before you go for the IoT applications, if somebody wants to go for the resource management, he can go, but you need to see what are the various constraints first. And thus, if we understand these constraints at the node, network, and the application level, we can see that there is a need of resource management, and in rather other words, there is a need of resource optimization. So what are the various techniques, what is the research that we have in today's world? Like there is a lot of research that is going on data aggregation techniques, there is research going on routing protocols, there is research on quality of service, there is research on resource virtualization. And this virtualization, they have done it on IoT devices, WSN devices. There is a concept of virtualization on cloud, there is a concept of virtualization on fog level or fog layer. There are certain other also, there are certain like we can say there is a research on IoT architectures also. And there is a section of research, the or researchers, they focus on the resource optimization techniques. So what are these? We are going to see this in detail, because for understanding resource optimization, you need to understand where is the resource optimization, like what are the various techniques, what is the current trend. So if I talk about data aggregation, as the term you can see, it aggregates the data. But how it aggregates the data? It aggregates and collects the data in an effective manner. If I talk about this thing, you have this IoT device 1 and this is the IoT device 2. I need to aggregate it somewhere on a device. Okay, this is the device D1, this is my computer, I'm aggregating the data, but it has to be done in an efficient way. What are the various techniques? There is like we can say there is a centralized technique. So if everybody reports to one data, we can say collecting unit, then it's centralized. If the structure is like tree, this reports to this reports to this reports to some other like node, so this is called tree. There are certain limitations also, there are certain advantages also. If we talk about centralized, the delay is less. Okay, there is only one hop that this IoT device has to travel. But if I talk about uh, the tree structure, the delay will be more, but there is a case that the redundancy will be less, because this data will travel to this, and there is some other data, same data, if it can travel to this node, and if there is a redundancy, we can check that. But in centralized, what you have these IoT nodes, the data will be replicated, and replicated. So there are some other advantages and disadvantages that you can see yourself, but I'm just talking about the techniques. Then there is cluster based, which is the most important one. Cluster based means each node will report to the cluster head, and these cluster heads are many. So your network is divided in the form of clusters. This is cluster 1, okay? It works in a centralized manner, and there is some other cluster also. So there can be this central point is called cluster head in this scenario. So clustering means you divide your network into clusters. And what is the structure of cluster? Each node will report ultimately or eventually the data is going to be on cluster head. And then this cluster head will report or send the data to the base station, or you can say a sink, or any laptop. You can take an example of a computer, you can take it as a sink. So this is a case that there are different scenarios. These have their own advantages and limitations. You can check that. But some of the performance metrics on which the data aggregation mechanisms are, like we have the research is going on data aggregation on these parameters. They tend to increase the network lifetime. Network lifetime means the operational life of, like, the operational duration of the network. Like, I have some network, it works for 12 hours. So if I want to optimize the resources, this network which was working for 12 hours will now work for 20 hours. So my algorithm is going, maybe I may have used some of the techniques in this, maybe centralized tree or cluster head. So the research, this group of the papers, they mostly focus on network lifetime, processing time. Data is more, how much time it should take to process the data. Okay, latency, how much delay there has to be, and bandwidth. So bandwidth is the another performance matrix that one can also focus on, using the if you want to go for the research in data aggregation. So these group of papers, what they have done, I have just around 30 to 40 papers that I have read regarding this. And what they have most of them work on WSN based applications. Now the very limited work is on IoT devices. Like IoT devices, I couldn't find much of the papers on data aggregation. So if there is some one of you or somebody who would like to work on this topic, they can go for this. This is one of the research gap that I'm talking about. Now there is also research in routing protocols. There are efficient techniques used for resource management. Whenever I say resource management, obviously they focus on optimizing the resource. So they focus on IoT energy management. So energy is taken as a resource here. So what they do, they try to optimize the energy utilization and balance the network load. Obviously, when you balance the load, when you balance the data that you have, you can optimize the energy. Then what the basically there is a relation between the data and the energy. Data size is directly proportional to the energy consumption. Like if you have a lot of data, you are processing a lot of data, the energy consumption will be more. So if you are managing this data, the energy will be managed. So if I talk about the routing protocols, what they focus on this data, how to process this, and accordingly they can manage the energy. There were papers, and these papers, they focus on this. Now most of the work is focused on clustering and shortest path based routing. Clustering, I have already told you. Then coming to the shortest path based routing, obviously these algorithms will focus on decreasing the energy consumption because there are lesser hop count now. If there are lesser hop, lesser distance to travel, the energy consumption is going to be maintained, like it will be decreased. There won't be more energy consumption. As a result, the network lifetime will be more. So most of the papers on on this routing protocol, these are again on WSN based applications, and very limited work is on IoT. Then there are papers on the quality of service where they focus on the various parameters. They try to balance certain things. For example, delay. There are papers they try to focus on energy and delay. There is research going on this. So quality of service parameters, we can focus on the various like parameters like delay, bandwidth utilization, power consumption, throughput, fault tolerance, and then there are resource constraints, which is an important parameters, which is our topic that we on which we are focusing. So, what are the various approaches? Multipath routing approaches are efficient in terms of KOS. So, they have focused on this. So, one can try this to have to get an idea how we can have the QoS parameters balanced. Then there are limitations that huge processing and storage demands are there, high energy consumption is seen, and so on. So how they have balanced it, they can have their own algorithm. I have the references at the end of the PPT later. If somebody is interested in one of the like topics, you can go through those papers. Now there is work on lightweight algorithms. Lightweight algorithms, according to this, you can see here, if this is a device and there is an algorithm that runs on this, okay, on the normal computer it's okay to run a huge sized or a heavyweight algorithm. If there is an IoT device here, already we know the resources are limited. Are you going to use heavyweight? No, we are going to design lightweight algorithms that can run well on these devices. For example, if we talk about the security, okay, you cannot run RSA and so on. You can run, but the energy consumption will be more. What we do, we go for certain lightweight algorithms. There is some few algorithms, TEA, tiny encryption algorithm, present is there, and so on, which you usually run on these resource constrained devices because the resources are limited. So if I talk about IoT, the sensor nodes have less power, consumption, and storage capabilities. The amount of data generated by sensor node is high. Yes. Okay. Then IoT network poses a major challenge in terms of resource management because we need to use lightweight frameworks and we need to design these lightweight algorithms for this. So this is the area of the research. So for example, in securing IoT, we have encountered lightweight security framework that satisfy the security properties and mitigate the computation and communication costs. So if you are trying to decrease computation or communication cost of a system by using the lightweight algorithm, again it has an impact on the resources. More computation, more energy, more storage it will require, more processing it will require. So it has an impact on the resources. So if you are going to use lightweight, obviously the resource consumption will be less. So you are anyway trying to optimize the resource. So there is other like section which we can talk about is IoT architecture. So IoT resource management or the optimization has been done at the architectural level also, and it tries to address the real-time constraints of pervasive application. By pervasive, I mean IoT applications. Okay, so then the emphasis is on optimizing resource management and allocation. So this part, these IoT architecture, they have focused on allocation of the resource. Okay, I have the architecture, I have fully designed home application, how I'm going to allocate the resources, how I'm going to use the devices, how they are going to interact with each other, what data they are going to share with each other. So that is where the allocation will play its role. And in this section, there are multiple factors on which they have focused. So if you study IoT architecture, you will definitely are going to see there is a work on energy, bandwidth, and latency, like how you are going to utilize, how you are going to improve these factors. So there are considerable work done here on fog-based architectures, IoT architectures for pervasive applications like smart cities. So you know the IoT is related to smart cities, and by pervasive applications, I mean the automatic application. Automatic applications mean smart applications, and we know IoT applications are smart. So there is also work on cluster-based IoT architecture. So these three things you are definitely going to encounter while studying IoT architectures. So the problem here is that there is no standard solution for IoT resource management. So if there is no standard solution, you can try you can try your research on that, and you can see how you can just try to improve more and more factors in this area. Now, the important factor is resource virtualization, which is an most important thing, or most important, you can say, area where the research for resource optimization has been done. And we have resource virtualization done at the node level, where we try to virtualize this node. Okay, the resources of this node are virtualized. And then we can have the network level where the entire network is virtualized. So if you talk about the SDN, SDN is somewhat related to this network level. I'm going to tell you that in detail. Then coming to the resource virtualization, it has been done at the internet level. So IoT level, there is container-based virtualization done in IoT. So you can encounter this very term. It is most likely to come in every paper of resource virtualization, which they have done on IoT. So the benefits are, you have fast creation and insertion of virtualized instances. You have high density of applications, and you reduce overhead as compared to the hypervisor based virtualization, which we normally use on the like the devices that have good storage and processing. So if you have done something in virtualization, that was because you have high end storage or high end like node on which you are working. If I talk about IoT, we use container based virtualization. These are somewhat lightweight. So most of the work in IoT virtualization, it has been seen, it has done at the hardware level, and predominantly in Raspberry Pi ports. You can see these terms will be in these papers. So less attention has been paid at the network level. So if we talk about IoT, there is less attention at the network level. However, some part of the work has been done at the node level, and that too at container based virtualization. So limited number of devices are also used for performance evaluation. So that's a drawback. If you have more number of devices in an IoT environment, you are trying to approach the reality where we can have more number of devices. So less devices means you are not touching the reality of IoT environment. IoT means you will have huge number of devices in your surroundings. So you need to evaluate your system for that you need more number of devices for performance evaluation. So there is work also in resource virtualization in WSM. So for that we use tiny virtual machines, which again the concept of container based virtualization is somewhat relevant to tiny virtual machines, but we use tiny VM for resource virtualization in WSM. Benefits are, it eliminates the memory limitation, prolongs the battery life, enhances the computational capability. And but we have seen one thing, that there is limited work in WSN virtualization at the node level. So we have limited work here at the node level. Here we had some work at the node level, but there was limited work at the network level. Here we have the reverse. So how? Because at the WSN has collaborated with SDN, there are papers on WSN and SDN which works in for network virtualization. It tries to aim or manage the resources at the system level, reconfigures and controls the virtualized networks. It is very dominant in WSN. That's why I said WSN and SDN has collaborated together. Like we can say there is a collaboration, or there are papers, bulk of papers on WSN plus SDN. But there are limited papers on IoT and SDN. So one can work on that. So little exploration has been done in the IoT based network. So, talking about the virtualization in cloud computing, the virtualization concept started with cloud. Like there are various cloud-based solutions that perform the real-time processing on the go. They implement scalable, real-time, sensor-centric application. They try to manage the complex events. Complex events, in a sense, like for example, I have a device. You have a device like iPhone. Whenever there is a storage problem, what you do, you just push the data to the iCloud. You can subscribe some more data or more storage, and your data will be on the cloud. So this is a normal example of a cloud virtualization. It seems that your data is present on your device, but it is present on the account that you have on the cloud, like the storage that you have on the cloud. So these means we call these as complex events. So it makes them easy. It implements the task of loading for energy savings. Obviously, if we talk about IoT devices, if data is offloaded to the cloud, that means processing and storage, there is no need of these like these activities. We don't need to process the data at the IoT node level. All that will be done on the cloud. So this is task offloading, because energy will be saved. Whenever there is storage, there is processing, your energy will be lost. So this data, this task is done at the cloud level, so there will be some energy savings of the normal devices. Then most of the work is in resource management is done at the cloud level and not at the IoT device level. So one can club IoT with the cloud, and you can have a lot of things done here, and you can work on resource optimization as well. How we can optimize the resources of IoT device with the help of cloud and the technology. What we are going to use, we are going to use virtualization. So this is how we connect. Then there are few papers. These are very limited papers on the fog virtualization. IoT applications can be pushed to the network edge by incorporating virtualization. There is work done on SDN based fog computing solutions. The benefits include the reduced delay, improved bandwidth utilization, improved IoT lifetime. But research in fog virtualization is in its very beginning. Like there are very limited papers on fog virtualization as compared to these, as compared to the cloud, SDN, WSN, and even IoT. It is in its very beginning. So talk about if we talk about the resource allocation, which is one of the main activity by which we can optimize the resource, there is work done on resource allocation. The main goals of IoT resource management is that the IoT applications, as we know, every IoT application will depend on physical and virtual resources. The how much storage I have, what algorithm I am going to use. So every IoT application is going to be dependent on physical and virtual resource. So if you processing of the application incur workload for the IoT system, the resource allocation will accommodates this workload. So whenever data that this IoT device has sensed, I am going to process this data. It will incur the workload. And how I'm going to accommodate this workload? By allocating the resource. So proper allocation of physical and virtual resource is very important for the IoT resource management or resource optimization. So there is a need of there is a need of identifying the resource requirements for every application. So that's why I was talking about, you need, before you go for the research in resource optimization, you need to identify what are the various constraints, and you are going to work for those constraints. If there is a limitations, and how you are going to optimize the that limitation. Okay, there is an energy limitation. How I'm going to optimize that energy? For that, there is work in resource allocation also. In WSN, we have encountered papers. They have mainly focused on how we can have the battery utilization for the longer time. Most of the algorithms related to resource allocation, they try to maximize the battery life. There is a resource allocation in IoT, that's an open issue. That means not much of the work is done in resource allocation in IoT. So there is little focus on finding best configuration that corresponds to optimal resource allocation. Optimal resource allocation associated with impact of application assigned to the network. So there is very limited application related to optimal resource allocation. And also we have seen that resource allocation in IoT is an open issue. Then there are different parameters. We can expose them to be tuned for optimization purpose using resource allocation. Now, what are these parameters? These are, you can focus on network lifetime, how to improve this, throughput, latency, processing time, transmission time. So all these are the parameters. If one can conduct the research or carry on the research on resource allocation, so these are the factors on which you can focus. Okay, so then if we have seen all these techniques. Now the main aim of these techniques was to see what are the various challenges that we face in the IoT resource optimization. So if we know the challenges, one can carry out the work, and even we can get the motivation to work on these. So the first thing was to understand the area, the smaller parts of the work on which the work has been already done, so that we can shortlist the various challenges that we have in resource management. So this is heterogeneity management. Then there is limited communication, limited computation, energy management, device management, resource allocation. So these are challenges. This is an open issue. That's why I have put it in the challenges section. Then there is a scalability problem. Then there is data abstraction and even data management. I told you in IoT application, the data is huge. So how you are going to manage this is going to impact the resource management, because data size is related to the resources that you have in this system. Now, what is the motivation? Like, why do we want to work in these resource constraint? Why one can work? As we know, IoT application, they fall into two categories, that is resourceful and resource constraint. Resourceful, a lot of work is done. Most of the work is done to improve the services offered in the application. But if we talk about resource constraint IoT application, a lot of the issues and challenges are yet to be taken for research, especially in resource constraint IT application. There are resource constraint at different levels. There are challenges in implementation, like there are challenges in terms of how we can aggregate the data, how we are going to manage the heterogeneity, because IoT environment, there will be heterogeneous objects. They will have different processing capabilities, they will have different specification, how they are going to communicate with each other. Okay, they have different formats of the data in which they store by they are different formats of the data. So how they are going to interact, how we are going to integrate this data. So there is a heterogeneity at different levels. It can be in the form of device, data, and so on. Like how we are going to deploy this node, how we are going to allocate the resources, how we are going to manage the resources. So there is a need of resource optimization in IoT at the node and the network level. So now I'm going to talk about the design, how you can do the design and modeling of such applications. I have taken this Edge IoT application. You can simply say it is an IoT application, where you have three layers. At the bottom, you can have IoT devices. Okay, I have formed some clusters here. I know I'm talking about the IoT devices. They are resource constrained. There is a limitations in terms of like storage is limited, processing is limited, energy is limited. Now once it senses the data, it pushes the data to the next layer, which is this edge devices. Okay, these are resource constrained, but these are resourceful as compared to IoT device. Okay, so if I talk about three layers that I have here, is I have this IoT device, the resource. If I talk about R1 are the resources of this layer, then this is edge. R2 are the resources of this edge, and there is a cloud. If I denote it by R3 are the resources of this cloud, then it says the resources of IoT devices are always less than the resources of edge, which is always less than the resources of cloud. Okay, cloud is resourceful. That's why, because of these resource capabilities, we're trying to push the data from the IoT layer to the edge to the cloud. So before you start with taking any application, you need to have the design and modeling of these IoT applications. If I talk about the IoT node, you can start with an IoT node is defined as a five tuple. The first, you can see here, we have ID, which is the ID of the IoT device, and then you can say we need to know the status of the IoT device, and it can be in the form of 0 or 1, where 0 and 1, it symbolizes the inactive and active states. Then there is DI, that indicates the data item that this node senses. And then I have also placed this IL, which means the location. Like every node has to be placed somewhere, and this node will have some location. So there will be some longitude and latitude values that we can provide to this node. And then the location has to be gathered with respect to the timestamps, like at which time. Okay, this node, because there are certain nodes, they can be mobile. I can place them at time t1, I can place them at one location, and at time t2 I can place them at some other location. So this you can see there are some other parameters that I have also talked about. Like if I have this IoT node, I'm going to represent this. You have to do the mathematical modeling of these IoT nodes. Okay. Then there are certain things. For example, I am concerned about resource optimization. So I'm going to represent these resources in some form. of this IoT node. So how I have used this, how I have represented this is EBMP. You can see this. E stands for energy. This is the bandwidth. This is the memory. This is the processing. Because we have categorized the resources into four types. Then talking about the edge, for every edge there will be the ID, then the type of the edge, whether it's a gateway, router, or some other system that you have used. Then there is er stands for the resources of these edge, which I have represented in this. Now you have, for the cluster to be formed, every IoT node, you can you can closely located IoT nodes can be grouped together to form the cluster, right? Based on the location of this IoT device, it may leave or join any cluster. So this is the cluster ID. This IU represents the what are the various IoT nodes that we have here, and EID represents the ID of the edge node. So you need to understand that whenever you form the cluster, you need to see, okay, what are the various neighboring nodes, how we can form the cluster. Like there are certain algorithms, they randomly choose the cluster head, and accordingly, the neighboring nodes can form as the participants of that cluster. Now there are two scenarios. See, if we talk about the cluster, there are uniform and non-uniform clusters, and then also we can have overlapping and non-overlapping clusters. So if I talk about this, for example, here, if we have these cluster, this is a cluster head, and 1 2 3 4, these are the IoT nodes. So every cluster head is going to have four IoT nodes, so this is somewhat uniform. If I have here 5 6, and this is different cluster and this is a different cluster, this means non-uniform. That means the nodes are not equally distributed. Here we have the nodes that were equally distributed. And if we talk about the overlapping, for example, if I have a cluster here, if this is a cluster here and I have this node, it belongs to this cluster, but at the same time it belongs to this cluster also, depending upon the distance. So these are overlapping cluster. So before you go for the mathematical modeling, you need to specify what are the features of your applications, and you need to see whether the clusters you are going to deploy in any IT application, maybe agricultural field, whether they are going to be overlapping or non-overlapping. Then talking about the resource, so we know that I have already told you the edge node is resourceful as compared to IoT nodes. That means the energy will be more, the bandwidth of edge, the memory of edge, the processing power of edge will be more as compared to the resources that we have in the IoT node. As need for computation increases, the edge becomes insufficient, and in that case, whenever the edge becomes resource constrained, we connect it to the cloud. So that's why I have already told you here, that's why we push here, we offload the data whenever these layers become insufficient to handle that data. So that's why I'm pushing the data from edge to the cloud. So talking about the various things, these are some of the real-time data that we have gathered. We have gathered the size and the processing power of the many devices. These are some range of the devices that we have. For example, we have gathered the body area network devices, agricultural devices, then we have high-end devices. You can see the size has an impact. It says the less the size, there is an impact of processing power. The less the size, there is a problem of battery. Okay, lesser the size, there is a problem of storage. So if you can go with the concept, like there is a book on IWSN, and it is on the size factor, how size has have an impact on the resources. So you can also see this parameter as one of the constraints. So size, they have talked about this very fact, that the size of the IoT or a WSN mode or any other device that have an impact on the resources. So this is how these graphs depict the same. Okay, so this is the clarification of this. So I told you the resources are less, of the IoT devices are less as compared to the edge and so on. So these graphs are the range of the devices, these range of devices, which shows maybe these edge devices are these, and these are your IoT devices. Okay, the small resource constraint devices. So there is a need of resource management IoT architecture. We know what assumptions are we going to take. We are going to take that the resources are non-rechargeable, non-replaceable. They are battery powered. That means they have limited energy. They have limited bandwidth, processing time, and storage. And IoT device is going to calculate their residual resources. Edge nodes have more capabilities, and edge node maintains the ID of the IoT nodes. Okay, the edge knows what are the various IoT nodes that we have. For example, if I talk about here, if this is the edge layer and this I have a device here E1 and these are the IoT 1, 2, 3. So this edge knows which IoT devices are pushing the data. So it needs to know the IDs of these IoT data that are related to this edge. Okay, we have a we if we talk about this. So then coming to the next point, which is cloud. So cloud will maintain the ID of edge. Now I told you this, there is a tree sort of structure that you can see different. Now this, there can be edge 2. Okay, this I3 and I4 is reporting to edge 2. Now this E1 and E2 are reporting to some, maybe a block here, cloud. So you can see there is some IDs that it has to maintain here. We can have different containers here, you can see. Okay, so this cloud maintains the IDs of these edges, these IoTs. The IDs of these IoTs are maintained here. Okay, so this is how we are trying to build the concept, or we are trying to build a system for IoT resource management architecture. And you can see the resource management can be done at the perception layer, at the communication layer, at the processing layer, at the application layer. Here you can see you can make use of some other, like I have already told you here, these are the techniques. So some of the techniques have been used. This resource allocation, you can use it at the cloud level, at the application level. So you have this virtualization, which you can do at the network layer and also at the IoT device layer. I told you there are two types of virtualizations here. Likewise, whatever techniques I have told you, like the routing techniques and data aggregation techniques, you can understand that you can perform the resource allocation or resource optimization or management at these layers. It's up to you where you want to work. So talking about the resource management architecture, you can see there is a perception layer. You have a node. Okay, I have IoT devices. There will be a device ID, there will be some sensor data, and now you are going to have the resource parameters, right? You are going to save the resources of these IoT device, how much energy is left, how much energy it had, how much storage it has, and so on. So there will be a mini profile of this node. Then the many profile, whatever is it senses, whether it's a sensor data or a resource parameter, it's going to communicate this to the processing layer. So if as a patient we can have IoT device, okay, and if there are n number of IoT devices attached to the patient, we can have number of mini profiles here, and these mini profiles can be combined to profile. Okay, there will be a patient profile. Then these patient profiles can be combined at the cloud level, and we can have a huge number of patient community. I'm just giving you the example of healthcare with respect to the this architecture. So the at the application layer, when you have different profiles, you make the community and you can have the recommendations accordingly. So there is a resource management layer which can take care of all these, like all these layers. And what it has to do, it has to manage the limited resources of IoT devices, the storage, energy, processing, and bandwidth. These are normally deployed as protocols and algorithms in the IoT framework. Now, what are the various functional fundamental functions of IoT resource management? It is discovering the resources, estimating the resources, monitoring the resources, allocating the resources. So first of all, you will discover what are the various resources that you have. Then you are going to estimate how much resources you have, and then you are going to continuously monitor. Okay, the device had a storage of S. Now it has S minus N because N it has already used for storing. So that is monitoring, the continuous monitoring. And then allocating. Allocating means how much resource you can allocate them. So for that, you require continuous monitoring. And for monitoring, you require estimation. So all these steps are interrelated with each other. The primary the most important use of this resource management layer is to optimize the utilization of available resources in IoT system. So if you talk about the resource management in edge IoT, where we have IoT, edge, and cloud, this will work like this. These are the, like you can see, these are horizontal layers, and we have a vertical layer, because you can have resource management at any of these layers. In all of the layers, in any of these layers, it will help you to optimize. So then, now if you talk about the design and modeling, like we are just we have already done the design and modeling here. Now I'm going to show you the design and modeling with respect to this edge IoT. So, in this system, you will have IoT nodes and edge nodes, and there will be a cluster formation. How? Dedicated set of IoT nodes will be assigned to this edge. So, sensing, processing, and communication of data will incur workload, such as sense, process, and transmit. This is the workload, like they have to do this, like they are meant for this. So, this can be interpreted as the resources needed to accomplish specific application task. So, if you talk about the data model, if you do the modeling of this very system, IoT device will report to edge. Edge is going to push the data to the cloud. So how I'm going to do this? There will be a data model. IoT nodes will sense the data here, and I'm going to aggregate this on the edge. And this mechanism is called data offloading. And I will have a profile, like I will create a profile. One node will generate mini profile here, and different nodes can generate a profile. Then at the resource monitoring, what I have already told you, you just try to keep the track of the resources. Like you have energy, processing, you have memory and bandwidth. You just try to keep the track of that at the node level and the system level. Now, resource monitoring, it will keep track of non-utilized and available resources. It will reclaim non-utilized resources and return to pool of available resource. So if there are resources, there was storage that was taken for some time. Now this storage is given back to the IoT device, and you can utilize it. So if you talk about the abstract view of the information flow of in an IoT device, in an IoT device, the n number of devices are deployed. These are IoT devices, and they can generate data. This is the mini profile of monitored data, and at the same time, we need to keep track of the resource of each IoT device. So at the end, we will have monitor data. Okay, monitor data will be the data of these end devices, which we have clubbed together. Then resource parameters, these are the combinations of these. We combine, we aggregate this data, the monitored resources of each device. And at the output, what we have a profile at the edge, which is a monitored data and resource parameters. So there is also one section of resource allocation that you have to see here. The E will have every node will have the maximum values. For example, if I talk about this, I have node I1 and there is energy E1. I have taken some energy E1. That means I can allocate only this much. Minus this. This has been already allocated. This is left. So this is available to be allocated. This is what I need to understand, that this resource allocation, the aim of this resource allocation is to maximize the energy that I have. If I talk about energy as an example, so resource allocation will try to maximize. Yes, there are certain constraints which I have shown here, as the energy is limited. That means it has a small, some constant value. So you need to understand that the aim of the resource allocation is to maximize the resources that you have. Now at the IoT application level, here you had mini profiles. Okay, this IoT node was generating the mini profiles, and here you had profiles, and here you have the patient community. Here you have the IoT node of a patient, and here you have the patient, like the profile, and here you have the patient community. If there are n number of patients, they have the same problem, we can recommend them, or give them the feedback based on the patient community that we have created here at the fog level. You can call it as a cloud or a fog. It's up to you. It's up to your system that you have designed. Now there are various edge IoT scenarios that we have. We have static IoT edge nodes, we have static IoT and random edge nodes, we have random IoT and static edge nodes, random IoT and edge nodes. The only thing that you have to keep track of is that whenever I talk about static, that means the location is static. Whenever I talk about random, that means at different intervals of time you can change the location of that node. So there can be different scenarios. In static IoT and edge, you have static values. Location of all the nodes is predefined. So fixed number of IoT nodes can be associated to the fixed edge node. So resource consumption will occur because of processing and transmission of data. There will be one-time processing in calculating the parameters such as position of the node, distance among the node, because it is not going to change because this is the static scenario. So if this changes, there will be problem added to the resources. So the second scenario that we have is the static IoT and mobile edge nodes. IoT nodes have fixed location. So here fixed number of IoT devices are associated to the edge. So every time you have to calculate the position and distance of random edge nodes, not the IoT nodes. The IoT nodes have fixed. So here the degree of randomness is more as compared to this scenario. Then you can have mobile IoT and static. You know the number of IoT nodes are more as compared to the edge node. So if mobile IoT nodes are there, mobility is more. Mobility is more, that means it will drain the resources more quickly. And the fourth scenario is mobile IoT and edge nodes, where the degree of randomness is more. Any IoT device can be assigned or associated to any edge node. So that way you need to understand, the whenever the degree of randomness is more, there will be more resource consumption, because every time you have to calculate the location of mobile IoT node, every IoT node and every edge node, then the distance between them will change at different intervals of time. So the resource consumption is highest. So if the resource consumption is highest, what I mean to say is that you need to optimize the resource, you need to see. So that's why the main aim of today's lecture was to make you first understand what IoT is, and why we are doing the research in resource constrained IoT devices, why what are the various techniques, or what is the various, like, the areas where the work has been done. Then these are the areas where you can work these challenges. Okay, then if we can talk about the general IoT application, how we can model that. And once we go for the model, if I say this resources are limited as compared to the edge, we should have the proper, like, data for that. I cannot have the modeling done based on the assumptions of my own. No, I need to have the perfect proof. So these are the proofs. Then I told you there is a need of IoT architecture. Okay, we are switching to IoT architecture, but how we can relate that? How we can have the modeling done in this? We need to see the once you go for resource optimization, you need to see the data model, resource monitoring model, and then resource allocation model, because these are the major steps in resource optimization. Then if I talk about the scenarios, this is an important part. You need to see the degree of randomness, because more the degree, more the calculations required, more will be the resource consumption, and more you need to keep track of the resource management or resource optimization techniques. So this is my session one. I would like to take a break for maybe like 25 minutes or 30 minutes. After then, I'm going to start the session two, which will be the case study, and I'm going to deliver the session on smart IoT architecture. Okay. Are there any questions you can ask? Jahangir sir.
Among the audience, if you have any questions, you can unmute your mic or you can post it in the chat box.
So I have a question.
Yes.
Actually, what we see here, that we have a lot of IoT devices nowadays, and it seems that we are having a lot of resources, and we are utilizing in an optimized way as well.
Yes.
But my question is, how actually we see the feasibility of these devices? Uh, because in future we are having everything, we are having resources, we are having IoT device and many more, but actually will it be used in this way or not?
Used in what way? Like, I'm not getting your
एक्चुअली यानी हम
question.
कह तो रहे हैं बहुत सारी चीजें कि ऐसा हो सकता है, ये सब कुछ है, एंड बहुत कुछ चीजें हमने रियलाइज भी कर ली हैं, बट
हाँ हाँ.
फ्यूचर में हम कितना इसे यूज कर पाएंगे,
देखिए,
फिजिबिलिटी क्या रहेगी,
there is a
दैट इज
problem. There is a problem. Like in many of the countries, the research on IoT devices, they have banned it because there is a problem of like कुछ radiations आ जाती है, health hazards है. But as a case study, what I was saying as a research topic, because I can understand all of you are from the CSC background, like many of you might be doing their research right now. I'm taking the resource optimization as a problem statement. Like हमारे पास छोटे devices है, हम कैसे उनको optimize कर सकते हैं. Like problem ये नहीं है, we have a lot of infrastructure. I can have hundreds or millions of dollars that I can spend on the IoT application. But as you can see, जो भी हम use करते हैं, even if I talk about the cloud, कहते हैं 70% of the hardware utilization is of no use. ओके जितना हम हार्डवेयर लाया जितना हम इंफ्रास्ट्रक्चर लाते हैं इट हैज बीन सीन इट इज नॉट यूज्ड अप टू द मार्क that is what my problem statement is. If you are using a small IoT device, how we can optimize it? मुझे क्यों जरूरत पड़ती है मैं एज पे जाऊं, मुझे क्यों जरूरत पड़ती है मैं क्लाउड पे जाऊं? क्या मैं ये IoT डिवाइस ऐसे यूज कर सकती हूँ कि लाइक आई कैन यूज इट टू द फुलेस्ट, आई कैन ऑप्टिमाइज द रिसोर्सेज दैट आई हैव. Second question is feasibility. Yes, you are correct. Feasibility is an issue. I don't know in the future. There are many theories on this IoT. Like some say there won't be any research in after 10-15 years because it has health hazards. Some say no, it will be of good use because आप देखिए बहुत सारे फॉरेन कंट्रीज में भी क्या होता है, आप देखिए वहां पे ये सब चीजें इंस्टॉल हो चुकी है. whenever somebody enters the home वहां पे गेट ओपन होता है, AC ऑन होता है. These are all the concepts of IoT. So feasibility I cannot say about the future, but I can say there are certain theories. Like some countries they have banned the research on IoT because of health hazards. But what I can see is that I was talking about how we can have the small IoT devices जिनके resources में issues है, हम कैसे वो optimize करें. So the session was on that, but like have I answered your question? Is that okay?
yeah, what I understand that what will happen in future is not, we cannot predict it right now
Nee,
actually,
yes, yes,
because as
yes,
you said that there are some health hazards,
yes,
and maybe in future we have to stop research on this area,
yes,
but still
yes,
since we are a developing country and we are looking into the
yes,
positive aspects of IoT, so we are still working on that.
yes, sir, yes, sir.
Okay, madam. Thank you.
Okay. Any more questions, please? Okay, Jahangir sir,
Yes,
when should I start
yes,
my second
yes, you
session?
can. It's up to you. You can take a break. You said कि
Yes, I just want to take a break for some time, maybe 20 to
10, 20
yes.
minutes.
Oh
Okay,
yes,
after
20
20
minutes.
minutes at
Oh,
11:30.
yes,
Join.
yes. Okay, okay. Thank
Okay.
you so much. Thank you so much.